This problem is about iron casting with cavities, and the question is, anytime when you cast an iron, there could be some cavities inside. So the question is, if there are some cavities, how do we figure out the volume of these cavities? Okay, now to do this, we can use Archimedes' principle to do this. All right, so let me give you a picture of something. So we are going to make iron. You're going to use pure iron, and they give you the density for that. Make a casting. All right. So when you make the casting, sometime what will happen is some air could trap inside and form a cavity inside. All right. So if I could draw a picture for you, so let's say that this is the object we are trying to cast, and then inside, uh, you know, if you are not careful, there could be some air inside. So let me draw a picture for the cavity inside. So let's say we have a small cavity here, there might be another one here or something like that. So the question is, this particular problem asks for the volume of all these cavities. Okay, so how do we do that? All right, so one thing to note is if the air inside these cavities, they are not going to weigh that much, because the density of air is very small. So basically they have almost no mass there, so we can ignore the mass of these air inside the cavities. Okay, that's going to help us to do this problem. All right. Okay, first thing is, let's try to find the volume. So we are going to find the volume using two methods. All right, so we can find the volume V using Archimedes principle. So let me use blue one for that. All right, so we could find the volume of the entire volume of the object. Actually, we can do that using Archimedes principle. All right, because Archimedes principle. All right, why? Because when you do the Archimedes principle, what happens is we look for the displaced liquid. All right, so this one is done in water. So it says the mass in air is 550, mass of 420 gram in water. All right, so if we do it in water, of course the density of water is 1 gram per centimeter cube anyway, so we are going to make use of that also. All right, okay, so when you do with Archimedes, what happens is we look for the volume displaced by the object. All right, so when you do that, what will happen is the object is going to displace the whole volume of this, including the metal part plus the cavities. All right, so when you find the volume using Archimedes' principle, it's going to give you the entire volume of the metal part plus the cavities. Okay, but then if you try to find the volume using um, density and mass, all right, so that density is mass over volume. So volume is going to be mass over density. If you do that, then in this case, remember that when we use the mass, we are going to use the mass in air, which is 550 gram. So that's going to include only the mass of the iron. Okay. So, and then we are going to use the density of the iron. So this is going to give you the volume of just the iron only. All right. So if we know the volume for just the iron, and if you know the volume for the iron plus cavities, then we can find the volume of the cavities. So that's the way you do this problem. All right. Okay, so let me do the volume with Archimedes' principle. So for that, I'm going to use the buoyant force. All right. So according to Archimedes' principle, the buoyant force is equal to density of the fluid times the volume, displaced volume of the fluid times gravity. Okay. But if I keep the buoyant force in grams, all right, then this becomes very simple, because so I'm going to keep this in grams. All right, so if I'm going to keep this in grams, I don't need to use G, so I'll drop the G. Okay, and then the density also 1. Okay, because of density of water is 1 gram over centimeter cube. Then what you see is technically the rho is also gone, so number wise you see the buoyant force is equal to the volume basically. Okay, now the unit wise they will match up, because the density of water is 1 gram over centimeter cube, and then if you put, so the volume should be in centimeter cube to match out the units, but number wise the buoyant force in gram is going to be equal to the volume in centimeter cube. Okay, that is if you do this in water, of course. All right, so let me make a note of that. So if the experiment, the Archimedes principle, Archimedes buoyancy is done in water, then we can say the buoyant force in grams is equal to the volume of the object, okay, in centimeter cube, basically. Okay, so that's the good thing about that. All right, so if you look at the problem, it is 550 to 420. So what's the buoyant force? Well, buoyant force will be 550 minus 420. So that's so if you subtract 550 from let's see, 550 minus 420, that's 130. So 130 gram is the buoyant force. So that means the volume, according to Archimedes' principle, right? I'm going to say then that's going to give you the volume for Archimedes. I call it, I guess, Archimedes is 130 centimeter cube. Okay, so this is basically the volume of the metal part plus the cavities. All right. Okay, next I'm going to find the volume of just the metal part. All right, so so to do that, let me use a different color. Okay, so that volume I'm going to use, as I told you earlier, volume is mass over density. So let's do that. So volume is mass over density. So let's calculate this. Now the mass, of course, we had to use mass in air always. All right, when you do this density ones. So I'm going to use 550 for that, divided by the density of the metal they gave you is 7.87. So if we calculate that, let me find out how much I get for that. So 550 divided by 7.87, that gives me 69.9. Okay, so this is 69.9 centimeter cube. All right, so this is the volume for only for the metal part, just the metal part right here. Okay, so we have two volumes. One is for just the metal and one is for the whole metal plus the cavities. What is 130 here and 69.9. So to figure out the volume of the cavities, all I had to do is take the total volume, which is 130. So let me write that down. The answer, I'm going to use a different color. So volume of the cavities equals, I'll take the 130 and I subtract the volume of the metal, which is 69.9. So if you do that, you get 60.1 centimeter cube. So that's the answer to this problem.